countries such as Greece and Spain, notably. Last but not least, before I introduce our moderator and panelists, for those that have a strong interest in solar and storage technology, I would like to propose our just a quick showcasing of our upcoming event, Digital Solar and Storage event, which will be held in Brussels on the 6th of November. So you have all the information on our website, and it is basically an event which is developed jointly by SolarPower Europe Solar and Storage Task Force and Digitalization Task Force. And so a lot of topics that we are going to discuss today are going to be also at the core of this event. So that's all for my side today. I am really happy to welcome our panelists. So Nathalie Rubin-Delanchy from Cambre Associates, which will be moderating this discussion today. Georg Hellmich from the German Federal Ministry for Economic Affairs, who will help us have a better understanding of the positioning of the German government and German market today when it comes to the development of storage technology. And finally, of course, Felix Dembski from Sonnen, which is also the co-chair of our Solar and Storage Task Force. And I'm really delighted that all of you can make it today. So I wish you all a very good webinar.
Many thanks, Aurélie, for this introduction. So as mentioned, my name is Nathalie Rubin-Delanchy. I'm an expert in energy policy, specifically at Cambre Associates, which is a public policy and public relations agency here in Brussels. And the reason why I've been asked to moderate today's webinar is because we've actually been following the Clean Energy Package negotiations for a number of clients ever since their launch, so back in November 2016, and we're still following the Clean Energy Package through its transposition phase now into national legislation across key member states. So in this context, we've been focusing particularly on the provisions around energy storage. So I'll be able to give you a bit of background on this. Before I kick off on general scene setting, I need to give you a few housekeeping rules, which I think are on our next slide. So just to remind you a little bit of the agenda for today. So indeed, we're going to have some interventions by Georg Hellmich and by Felix Dembski to explain the situation in Germany specifically. And after that, we will open the floor to a Q&A session. You'll be able to type your questions in the little bar, which should appear to the right of your screen. And we will pick up questions at the end of the webinar to pose them to the speakers. Okay, so just to give you a little bit of background on the current state of play for the Clean Energy Package. So the Clean Energy Package, and particularly the Electricity Market Design Package within this, is widely considered as relatively revolutionary for storage and other flexibility providers, as this is the first time ever that the EU writes down in law the rules for storage to actually be part of the EU's energy system. And this ranges all the way from having a clear definition of storage for the first time to the rules which will enable storage to actually participate in the EU's various electricity markets. What the text importantly also does is to enable many different applications of storage. So Aurélie just mentioned a few, but to go over these from the customer perspective, first of all, the possibility of using a battery to self-consume, but also to produce, store and sell electricity. So the possibility of actually becoming an active customer. And then for system operators, so DSOs and TSOs, there's also very strong incentives in the text to make use of flexibility. And this, for instance, by considering storage as an alternative to grid build-out when establishing their network development plans. Importantly, Aurélie also mentioned, again, the text enables stacking, so the segmenting of the battery's loads in order to be able to serve multiple markets at the same time. The transposition of the Electricity Market Design Directive was kicked off in June this year, and it was published in the EU's official journal. And since then, so over the past few months, EU member states have begun the task of adapting these guidelines to their national realities. And this exercise needs to be finalized by the end of 2020. what we're currently seeing after just a few months, so although this is at very early stages, we already know that the end result is going to look very different from one EU country to another. And this is simply based on the fact that EU member states have very different starting points. So they've got wildly different energy profiles. And we see this particularly is visible for the provisions that relate to energy storage. So as you know, energy storage can show its value primarily through having more dynamic and flexible markets in which prices are able to fluctuate. And this is where customers and industry are incentivized to think about storage as actually an interesting business opportunity. But this, of course, requires having market-based prices, which means putting an end to regulated tariffs and allowing demand and supply to fluctuate throughout the day, which would imply for many countries having a fundamental shift in the way the whole energy system is conceived. So there are definitely some challenges to be raised with the transposition phase. So in a nutshell, while the market design's provisions on storage are a very good starting point, the transposition is where we're really going to be able to see how this can actually play out in practice. And there are already some small drawbacks which the Market Design Directive has not addressed. So for instance, the definition of storage, although it's present, it doesn't recognize storage clearly as a separate asset category, so separate from generation and from consumption. And this has led or will lead in many cases to potential double taxation of storage, so both as generation and as consumption. What we're also seeing is that in many countries, including in Germany, although some rules do actually already exist in some cases for storage to participate in markets, in practice, technical specifications often make it difficult for storage operators to do so. The EU is aware to some extent of these issues and is already planning a number of follow-up legislations to address them, and these will be issued over the next policy term. However, indeed, even if the EU is planning follow-up legislation, it'll take another 5 or 10 years for these to actually come to fruition at member state level, which is why the transposition of the Clean Energy Package, and particularly the Market Design Directive, is so key for storage operators, as this is an opportunity for regulators to get policy right from the get-go. Today, we're going to do a deep dive into Germany's current status and what's being planned for the transposition, and looking at the key provisions on electricity storage and how these can play out according to Germany's reality. So without any further ado, I'm very happy to give the floor to today's first speaker, which is Georg Hellmich from the German Federal Ministry of Economic Affairs and Energy.
Well, first of all, thank you very much for introducing me and for organizing this whole webinar. Special thanks to Aurélie and Nathalie for setting this up, and everybody who worked in this, especially the technical stuff. Maybe as a quick introduction, my name is Georg Hellmich. I work for the Federal Ministry of Economic Affairs and Energy in Berlin. I've been working on storage issues only for the last couple of months, so there might be some things that I am not aware of, and if you can remind me of those, then I'll be quick to follow up, and if I can answer a question, I'll look into it. What I'm planning to do today is, yeah, I know, I see it. But I'm not able to change the slide. Okay, now it works. Well, I would like to give you a quick overview of the current regulatory framework in Germany. Then against this background, I would like to take a quick look at the relevant CP provisions for storage. As Aurélie already mentioned, there are just a number of mentionings of storage in the whole CP, but I'll try to focus on the most relevant CP provisions that I can think of and that we've dealt with during the last couple of days and weeks. And then I'll follow this up with a first few thoughts on implementation. As Aurélie has already mentioned, Nathalie has already mentioned, we are still in the first phase of the implementation period. So these are really just the first drafts. And now it should slide to the next slide. Great, thank you. What are the basic principles in the German regulation? Storage is not a distinctive market role. It's basically treated as a consumer or as a producer according to its electricity consumption or generation. And this has consequences with regard to the way that the German electricity system costs are refinanced. And in the German electricity system cost system, every consumer pays various levies, taxes, and charges on their electricity consumption, and these payments are all used to refinance the system. And this can lead to a situation where electricity storage could be charged twice. And the first step is when the storage unit consumes electricity, and then if it's fed back into the system, into the grid, there could be a second final consumption occurring where the final consumer pays a levy, a tax, or charges a second time on the same amount of energy, basically. And that's what we're discussing in Germany under the heading of double charge. So there are already a lot of exemptions existing in the German regulation or in the German regulatory system for various taxes, levies, and charges for electricity storage. But these were added over the last decade, and they're not, let's say, not very systematic. If you were, for example, a battery storage operator today in Germany, and your business model is basically to just draw electricity from the system and feed it back into the grid, for example, to offer to sell the electricity on the spot market or to offer balancing energy, then all the exemptions we already have in place pretty much apply to you, and there are just two or three minor levies that you still have to pay. But that doesn't apply to all the other applications that are thinkable or possible for the use of storage, especially when there's stacking involved, so the multiple application of the same storage unit. Furthermore, there are different requirements. Sometimes a certain exemption is limited to certain storage technology. This is for example, true for the electricity tax that we have in Germany. But what can be said about all the exemptions in general is that they require electricity to be fed back into the grid, and the rationale is pretty clear behind that. As I mentioned earlier, in the German system, all costs that occur, for example, for the electricity system, for example, for grid extension, grid operation, the renewable energy subsidies, they're all refinanced by the final consumer that needs to pay taxes, levies, and charges. And if there's no a storage unit is exempt from these charges, and there's no final consumer behind that, then basically for the amount of energy that is stored in the storage unit, there would be no one to pick up the fee, basically. Can we go to the next slide? Thank you. So this rationale is basically also the reason why we don't have any exceptions in general for energy storage. Now, this term might be not familiar to people from other member states, but in the German discussion, there's a difference between electricity storage units that are units that feed electricity back into the system or are used for self-consumption, or energy storage system, which where electricity is consumed, then stored and used basically in a different sector, for example, in a heating sector or in your electric vehicle. Against the background of the German system that I just explained, there's basically no exemption needed because although there's a storage process involved, it's just not so much different from the ordinary electricity consumption, except that the consumption process is delayed. And there's also no double charges occurring, since the electricity charges are only levied once when the electricity is, for example, stored in the heating system or in the battery of the electric vehicle. And if we were to have exemptions for those, this would basically mean that we have a missing money problem, that all the remaining ordinary electricity consumers who don't use energy storage units like electric vehicles or heating systems would have to pick up the slack for everybody else. Well, against this background, maybe a few introductory words. What we see in the CEP as basic principles regarding storage, I think Nathalie and Aurélie have already laid the scene pretty well. Maybe just a few things to add here. Storage is in general treated on equal footing with electricity generators, demand response, and aggregation. That is, as I've learned, new to the texts. Then we have this wide storage definition that I think Aurélie has already touched upon in Article 2, Section 59 in the Electricity Directive. That is not based on the use of energy in a different sector, but based on the deferment of electricity or energy consumption in general. But and I think that it was also already mentioned by Nathalie and Aurélie. The implications of this wide storage definition only really become apparent when you read this definition in context with the provisions further in the directives that really regulate how the storage should be used, what the requirements are, and what the consequences are. So what I would like to focus on is a few elements that I think are really striking in the new CEP regulation in general. I would like to quickly look at the Electricity Directive and the Renewable Directive. In the Electricity Directive, we can find the Article 15, Section 5, which deals with active customers and which basically says that they shall not be subject to any double charges for stored electricity remaining within their premise or when providing flexibility services to system operators. There we can already see that the energy storage regulation is quite limited to active customers and to certain situations where electricity is stored and then used within the premises or just for providing flexibility services. And there's another subsection which says basically that active customers are allowed to provide several services simultaneously. That is the, if technically feasible, that is the stacking we've already talked about. In the Electricity Directive, there's another two articles that I'd like to draw your attention to, or you probably already read it, that deal with the storage ownership and operation restrictions for DSOs and TSOs. In the Renewable Directive, I think the most important one is Article 21, sections 2 and 3. There are two different situations that I see in Article 21, section 2. That is basically the first situation that deals with the self-consumption situations where for member states should not charge any fees at all. And the letter B, which tells us again that there should be no double charges for stored electricity remaining within the premises. These letters A and B are somewhat conflicting because it's not really clear whether letter A is in the lead, which says that in certain situations there should be no charges at all, or letter B, which says there should be no double charges for the electricity stored and remaining within the premises. And there's also the possibility in section 3 that member states can apply charges and fees, for example, if the capacity of the renewable energy installations is above 30 kilowatt. So against this background, the current regulation that we have in Germany and as I mentioned, only a few new regulations that we see in the Renewable Energy Directive and the Electricity Directive. What are the first thoughts on implementation? Well, if we look at the question of storage and electricity consumption and sorry, that should be on the next slide. Oh, thank you. If we look at the situation, what happens with storage if it draws electricity from the grid or if it consumes energy from in a self-generation situation, we'll have to look at the remaining situations that we have in Germany where double charges occur. We have to make sure that this is regardless of technology. and is at least for storage units operated by active customers or in self-consumption situations. And this is where I'd like to reach out to everybody who's listening. I would greatly appreciate your input when it comes to telling us what are the situations that you see where double charges still occur. This really depends on the business model. Sometimes I don't think that we maybe know all the business models that are out there, so we might not be aware of situations where double charges occur. I would also like to say that I don't think we need to create an exemptions for the situations for energy storage. That means when electricity is stored and then used in a different sector. I don't see this as a precondition in either the electricity directive or the renewal directive, because essentially no situations of double charges can occur. The same thing is basically true for the consumption of self-generated renewable energy, and if it's combined with the application of the storage unit, they will have to look at the situation of remaining charges or remaining double charges, if in case the electricity remains in the premise. Going forward, this also I've already mentioned that there are few that there might be a few still barriers exist in Germany when it comes to storage and multi-use scenarios. So the stacking that we already talked about. I'd just like to draw your attention to one regulation that we have in store right now. Storage can only claim the renewable energy feed-in subsidies if the storage unit is exclusively fed with renewable energy. So there's no, as I'm aware, there's no balancing opportunity which would allow storage operators to tell grid operators, well, I use the storage unit 50% of the time to draw electricity from the system, and 50% of the time to feed in the renewable energy that I self-produce. And in these situations, you wouldn't be able to claim renewable energy subsidies. So that is, for example, a situation that we have to look at. And lastly, I would like to draw your attention to the question of storage and TSOs, DSOs. So the Article 36 and 54. I still can't switch to the next. Thank you very much. Oh, nope, that's not it. Should be the last slide, basically. Oh, thank you so much. Well, this is a bit harder to explain. So we have the grid development plan in Germany for the TSOs, and the German TSOs have proposed for the first time to install 3 large-scale battery projects. The idea behind these grid boosters is basically to squeeze everything out of the remaining the existing grid that we have. Right now, there's a huge margin for error, basically, that is included in the grid operation, the N-1 security guideline. And the idea is not to lower the standards of security, but to have maybe a possibility where a battery behind a usually congested line is operating somewhat as a fail-proof system, and that would allow us to, or that would allow the grid operators to push the limits of the security margins. That means in the times that we don't have a congestion problem or that we don't have a failure in the system, the transmission system operators would be able to power more electricity through the existing lines. This idea is not in any way, shape, or form an idea to reduce the grid extension that is already planned, but to, as I mentioned, to squeeze more capacity out of the existing grid. The grid development plan is of course subject to our NRA's approval, the Bundesnetzagentur. This is planned to happen at the end of the year. And in case of approval, this in case the NRA approves the grid booster concept as it is planned, or maybe in some other way, shape, or form, the operation and the ownership of this the storage units will of course have to comply with Article 54. I'm not aware of a situation where where DSO has maybe thought about adding something like a grid booster, but I still have to look into that. Maybe there's already a DSO also thinking about that. Well, that's about it for me. I'm sorry if I was maybe a little hard to understand. I have a bad cold, so if anything else is maybe unclear, then we can maybe come back to that in the discussion period.
Many thanks, Georg, for that very good introduction to Germany's specific context. And we already see a number of points that will need a lot of careful consideration to adapt to Germany's reality. So in this context, I'm very happy to now give the floor to Felix Dembski from Sonnen, who will give us a bit more of a perspective from the industry side.
Well, thank you very much, Nathalie, and thank you to the good people at SolarPower Europe for starting the conversation on how we can implement the clean energy package. Quick background: my name is Felix Dembski. I'm the Vice President Regulatory at Sonnen. We are a market leader for home storage systems. We have some 40,000 systems installed worldwide, and we connect those into a large virtual power plant, which is now certified to provide, for example, frequency control services in the TenneT TSO control area. And we also do a lot of research and pilots with grid operators how to store regional excess wind power in our home storage batteries using blockchain technologies. I would like to begin with a very simple number. And that's that the German National Regulatory Authority estimates we're going to see 8 to 10 gigawatts of PV storage by 2030. And they also estimate we're going to see another 8 to 10 gigawatts of different types of storage as well. So the regulator in Germany is typically conservative in their estimations. So we see that there's a lot of potential for storage coming up over the next few years. So it's very important that we have to get the regulatory framework right for storage to make sure that these 10 gigawatts and the other 10 gigawatts actually benefit the system as a whole. And what I would like to do is just give you a quick rundown into the provisions of the clean energy package, which tries to achieve that. So the first one is the rules on active customers with storage and regarding double charges and grid services. Why is the CEPs focusing so much on the active customer? Well, I think that's because the active customers are actually the ones who drive the public support for the energy transition as a whole. Those are the people actually on the ground level who choose to adopt these new green technologies such as solar and storage, electric vehicles, electric heating, etc. So the EU rightfully puts them at the center of this legislation, which shapes the provisions on a national level for the next 10 years. And one of the major issues for active customers today, Georg Hellmich already touched on that, is the issue of double charges and grid services. So what's the potential for active customers with storage and providing grid services? Well, what you can see on the left-hand side is the solar generation over the year in Germany and the wind generation right next to it. And what you can see is that they actually match quite perfectly. There's a lot of solar during the summer, and it almost disappears for 4 months during the winter time. And wind is exactly the other way around. Wind is massively present in the winter time, and if it's a good summer, it slightly disappears during the summer months. So what this means for us is that in Germany, 75% of the yearly installed solar capacity is still rooftop solar. And that is more and more often supplemented by storage systems. So what we can see here is that despite other services you can do with storage, especially during the winter months, you're going to have 10 gigawatts of storage capacity sitting idle in the basements of the customers, not having much to do, given there's not much sun. The sun isn't shining, so they would remain idle while the entire system is drowning in wind power and would really require storage solutions at this point. So we need to make sure that active customers actually become active and activate this capacity of storage for the system as a whole. However, where we are today in Germany is pretty much the other way around. What you can see on the right-hand side now is a little picture of the standard use case of standard home storage today, is where you effectively just optimize your self-consumption using a solar panel and draw some electricity from the grid if the sun doesn't shine. While if you then decide to become an active customer, what happens is you can actually use your storage facility to store excess wind power, to provide frequency control services, etc., etc. And what happens to you is you do the right thing for the system, but your electricity bill doesn't actually go down, it goes up. And the reason for that is the so-called issue of double charges, meaning that in Germany, storing electricity counts as consumption. So there's a 21 cents per kilowatt hour of charges, fees, levies, taxes, etc. Levied on your consumption. And it's called double charges because these fees and levies and charges, they apply despite the fact that when you store the electricity, you pay them, then you re-inject the electricity into the grid, and somebody else at the other end of the grid actually finally consumes that electricity, but he pays those 21 cents again. So we have a double taxation issue here at hand once you try to become an active customer with storage today. What that means is that the active customer enters the markets for flexibility with a 21 cent per kilowatt disadvantage compared to the other market participants. We all know the markets for flexibility, that's gas-fired power plants typically. So those are generators, and generators don't pay any charges or fees or something for grid access. So they have a huge advantage within these markets compared to active customers today. The German lawmakers actually realized that problem and started to implement exemptions like Georg Hellmich described earlier. But those have proven to be either non-applicable or not technically feasible for active consumers. So there's one notorious section in the German renewable energy law, 61L, which has proven to be so complicated that I am not aware of any home storage provider who has been able to make use of that benefit, which was actually intended to benefit him. So what's in the package for this issue? Well, the package now says in Article 15 quite clearly that active customers that own an energy storage facility are no longer subject to any double charges when providing flexibility services. Georg Hellmich already mentioned that provision. It's also nicely backed up by the market design regulation, which states that balancing markets shall ensure non-discriminatory access for energy storage, and that network charges shall not discriminate against energy storage and shall not create disincentives for participation in demand response. So the system we have today, where you're technically allowed to play in the markets for flexibility, but you have a disadvantage of 21 cents per kilowatt hours compared to the other market participants, that would also be at odds with the market design regulation there. So what's the call to action for us in Germany right now? Well, we should really try to unleash the potential of storage. There's huge technical potential in distributed storage, also in centralized storage. And I think we should really think about how we can make sure that this potential of these future 10 to 20 gigawatts is actually unleashed for the benefit of the system as a whole. And we have two options of doing that. I think we can do a limited implementation, so we can do piecemeal exemptions from these individual charges, change 8 different laws which put levies and charges on consumption of kilowatt hours, and we can also limit that to flexibility services. The EU only says that you should not pay double charges when you provide a flexibility service. So we can do a very limited implementation, or we could go deeper and define storage as a distinct activity within the electricity system. And then if we don't define it as consumption, then those levies and charges would go away. So those are two different options. We can also mix them up and have a middle way there. Of course, from my side, I would of course prefer option B, because I think it would solve also other contradiction storage faces in other fields. But I think we should start a discussion which is the best way to go there. All right, that was the issue of double charges. The next big thing in the package is for active customers is the issue of several services at the same time. Again, what is the potential there? Well, the potential is there's so much you can do with storage, and we actually have a very interesting example here. On the left-hand side, what you see is the big battery built by Tesla in Hornsdale in Australia. And this storage system bids into 12 different markets or mechanisms at the same time. Now we can count the rows of battery systems, and you think, oh, there's 12 rows of battery systems, so each row bids into one market, and the answer is no, it doesn't. Some bid in some markets and some bid in other markets. The whole system seems to be compartmentalized and has split capacity, which in a hierarchical fashion bids into different markets, etc. If you ever have the chance of the Tesla people presenting that to you, I highly recommend it. It's very, very interesting. And it can do that at the same time. So the potential we have with storage is that it can stack services quite neatly and can be reconfigured on the spot which service is the one the system needs the most, and it can do that emission-free. Where we are today in Germany is slightly the opposite. Again, you have your little self-consumer there, and he's self-serving, you could say, but also the self-consumer provides typically one service. He can store green electricity, and then he sells that as green electricity back into the grid. However, once he starts to add another service, let's say provide frequency control, what happens is he can no longer provide the first service. So the gray electricity from the grid, which you can see on the right-hand side, it comes into the storage facility and it poisons all the good green electricity in there. Even if it's just a little bit of gray electricity, it poisons all the green electricity in the storage device, and that turns all gray, and you can't provide that service of selling green electricity anymore. That's just one example. There's other examples where you have disadvantages from providing more than one service. This comes down to a very German concept, the principle of exclusivity, long German word, Ausschließlichkeitsprinzip, which leads to that phenomenon of green to gray. I don't want to go into super depth with that because that is really hardcore energy law. The way you want to understand it, if you are not familiar with the German market, is that in Germany, installations have properties and kilowatt hours typically don't have properties. So installations have one set of properties, and all the kilowatt hours which flow out of that installation inherit that one set of properties. While if you use storage, on the other hand, storage system can have so many properties and would like to, of course, that the kilowatt hours which flow out of the storage facility would inherit several properties. Like I can store green electricity, I can store gray electricity, I can do both. I can provide flexibility services, I can provide self-consumption, etc. So a storage facility can actually have quite a lot of different properties. Now I see a cursor moving there, which to me seems as if I can no longer switch through the slides. Is that true? Okay, so now I'm back in control. So what's in the package for this issue of stacking of services and several services at the same time? First of all, the Renewable Energy Directive tells us that renewable self-consumers can store and sell their excess production of renewable electricity, including through renewable power purchase agreements. What's important here is to understand if you use solar and storage, you can store and sell your electricity as renewable electricity. You've produced it green, you can sell it green. And of course, you have the right to receive remuneration for that. And now, on top of that, Article 15 now says active customers that own a storage facility are allowed to provide several services simultaneously if technically feasible. So I think the German way, which we do it, which says, of course, you can sell green electricity as green electricity, but only as long as you provide one service. And once you provide a second service, you can no longer do that. That would be at odds with this idea in the clean energy package that you have the right to stack services and sell your green electricity as green electricity. So what's the call to action there? Well, we need to find a way to allow for multi-use and several services in Germany. And I think the best way to do it is to think about it to begin with is how can we make sure that kilowatt hours which enter a storage facility are able to retain their properties when they are stored. I think that's the goal behind this idea, so that the storage facility can make the most of its technical potential. Again, this is just first preliminary thoughts to start the conversation. We can do this in two different ways. We can have a very detailed approach. We can trace every kilowatt hour and its properties as it wanders through the storage system. This is what a lot of the blockchain people are working on, and we also are active in pilots there, that we can actually trace individual kilowatt hours. Or we get a more pragmatic approach and just split capacity and say, well, if 50% gray electricity and 50% green electricity go into your storage system, it's probably 50-50 also when it comes out. The idea of splitting capacity is not entirely alien to German renewable energy law. We have it in other sections of the renewable energy law as well. Again, here we should have a conversation. How detailed do we want to get and how pragmatic do we want to get? All right. Those were the big two for active customers, that is double charges and stacking of services. I now want to quickly point your attention to three other provisions in the package, which I really think are important, which you may want to read up to if you find that interesting, but I'll keep it slightly shorter when introducing them, but I think they're also very important for storage as a whole. So the first
Felix,
one. Yeah.
Sorry, this is Nathalie just jumping in. We've only got a couple of minutes left for your intervention, if that's okay for you.
All right, I'll cover the last three rather quickly.
Perfect, thank you.
So what's in the package? Very important. Article 15 states that active customers shall not be subject to disproportionate technical requirements or procedures or charges. This is very often overlooked. This is a new thing in the electricity system. Typically in the electricity system, we only apply the principle of non-discrimination. Everyone's treated the same. And if you as a household customer want to enter a market, you may be treated the same way a nuclear power plant is treated. And then very often small customers stay away from markets. This will no longer be feasible. We have to make sure that we treat people disproportionately with the burdens of charges and procedures, etc. The next big thing is the idea that in the future, I'm sorry, it's very irritating to see the cursor and then it doesn't move when I try to click forward. So the next big thing is that Article 32 states that in the future, DSO level system operators must procure flexibility as well, especially also from energy storage. We in Germany at this moment don't have a DSO level flexibility mechanism. So we have to look into how we set that up and how we make sure that DSOs also tap into the potential of storage as a service. And the last big thing I think, which is going to shape the discussion quite a lot, is the articles on ownership of storage. So it states the principle of classic unbundling, that grid operators shall not own storage facilities, but they have two ways out. One way is to declare a storage facility a fully integrated network component. That's a new term. Nobody really knows what that means. Or the other thing they can do is they conduct a market test. So they have to ask the market, before they buy their own storage facility, they have to ask the market, dear market, do you have a solution as storage as a service for me? And only if nobody raises their hands, then they can buy their own storage facility. So I think the discussion will be shaped quite a lot about what is a FINC, what is a fully integrated network component, and we should be careful to limit that to the utmost exemptions. And if the grid operator has to do the standard procedure, which is the market test, we should really make sure that the grid operators present the market with a problem, that they don't just ask who wants to build a 5 megawatt lithium-ion battery in a container next to my substation in blue, but rather say, I'm going to have real trouble on this street. There's the 12th Tesla now there. I'm going to run into trouble. Who has a storage solution for me? And that's the last remark from my side, we should also make sure that it's equally financially attractive for DSOs to TSOs to contract storage as a service as it is to run their own storage facility. Because the way it is done today is whenever you own an asset as a grid operator, you get a regulated return on that asset. While if you buy something as a service, you just get your money back, but no regulated return on top. So we have to make sure, and this would create a disincentive for grid operators, that they would always prefer to own the asset themselves rather than to buy it as a service. And when we create these market tests, etc., we need to make sure that storage as a service is equally attractive to DSOs, TSOs than running the hardware themselves. All right, that was a quick run through the other three important provisions. And now I'm looking forward to the discussion and the questions.
Super, many thanks, Felix, for your introduction. Also very detailed and very, very good in terms of the current technical barriers that exist on the German market for storage. As we only have 6 minutes precisely, we have a hard stop at 12. I will pick up directly with some of the questions from the participants. And since we were just discussing grid boosters, one immediate question that arose was how many times are the grid boosters planned to be used per year? And why are we not procuring these storage services from the markets instead of building batteries directly? I guess this is a question more for Georg. Any views on this, Georg or Felix, if you want to jump in?
All right. Okay. Now. Maybe I'm not should I react to that, or because there was some mix up with the microphone, I guess. Well, first, thank you for the question. My first answer would be there's still an investigation ongoing on how often these systems would operate within 1 year or within a couple of years. This is worked on by one of my colleagues. The second question really is a question of procurement. As Mr. Dembski has already mentioned, the TSO would like to own these facilities, but at the end of the day, we'll have to look at the regulation in Article 54 and the possibility of labeling these as a FINC and find a solution for that. There's no up until now I can't really comment on that.
Okay, thank you very much in any case for the response. And just to clarify, because I saw a couple of questions also on this, indeed, the Market Design Directive does forbid in theory TSOs and DSOs to own storage in Articles 36 and 54 unless there are specific conditions. Maybe another question which was raised by a couple of participants, and this responds to actually one of George's questions during his presentation regarding when there are double charges on the the network and cases when these arise. So it was flagged that maybe for electrolyzers, as these are considered as active customers, there may be some issue with the double charges, and also for fuel cells due to the fact that fees are coming in from the electricity and gas sector. So is the government planning to look at these two specific cases in its review of double charging for storage?
I think I tried to make that clear at the beginning. What we see from the electricity directive is basically one thing. We have to get rid of situations where double charges occur. If, for example, an electrolyzer or a fuel cell is used in the way that it draws electricity from the grid or from a self-consumption situation, then turns that into gas or whatever else, whatever other meaning of storage, and then returns the energy as electricity into the grid, and we have a possibility of billing the final consumer, then this would be a situation where we try to look in an exemption for fuel cells and electrolyzers. But as I mentioned, I don't see any reason why we should exempt energy storage as a whole entirely. Because we will in Germany run into a problem of refinancing the whole system if we, for example, don't levy the costs on electrolyzers which produce gas, for example, and then the gas is used in a different sector in the industry, for example.
Okay, super. Many thanks for that response. Maybe one other sort of related question concerning a case where stacking is prevented and the business case is not as positive as it could be. So the current limit to storing EEG electricity and at the same time, the current limit to storing EEG electricity and at the same time providing grid services is a barrier for storage development as it prevents revenue stacking. Is this going to be lifted?
I'm not familiar. What provision are you referring to? This I would have to know that. Are you referring to section 61A in the Renewable Energy Code, or is it something else?
Felix, do you know this provision?
I can reverse engineer, I think, what this question is supposed to mean. I think what the current exemptions from the renewable surcharge for self-consumers is set at a limit of 10 kilowatt inverter capacity, effectively. The question is, will these? I believe the question is, will the limitation from 10 kilowatts be raised to something like 30 kilowatts? What's also like a limit in the Renewable Energy Directive.
All right, yeah, now I get it. We'll certainly have to look at that. I've already mentioned that in the presentation, but there hasn't been a decision on that. We are aware of Article 21, Section 1 and 2, which seems to indicate that that there should be no double fees and sometimes even no fees at all on a situation where you have self-consumption only, and this obligation for member states is then lifted in Section 3 on a couple of conditions, and we'll certainly have to look at those in order to implement the Renewable Energy Directive. Hello, anybody there?
Yeah, Nathalie, we cannot hear you if you. If no one from SolarPower Europe is here, and we cannot hear you, I would just assume the role of the moderator, and looking at the clock, it's 12 o'clock sharp. So
I think Nathalie is back online. Maybe she can jump in.
I'm back online. Sorry about that. I don't know where you lost me exactly.
We didn't hear from you after George's statement.
Sorry, okay. No, I was just wrapping up with a very final question, since we've indeed reached the limits of our time, just to hear a little bit from both of you as final remarks, so both Felix and Georg. What do you see as the biggest opportunity which the clean energy package can bring to Germany in terms of developing storage on the German markets?
Maybe, do you want to go first, Felix, or do you want me to, I don't know.
I'll do it real quick. I think the biggest opportunity is that the active customer is put at the center of regulation. It's that the EU has understood that we need to get people on board and take charge of the energy transition themselves. We will no longer be able to try to organize an energy transition in the background, which is economically efficient, but then runs out of public support once the people see all these wind turbines and large grids next to their backyard. So I think the most important thing is put the active customer at the heart of the energy transition, and then try to make adopting new green technologies fun. And I think there's great provisions in there which can make that happen.
And Georg, for you, what do you see as the biggest opportunity?
I think it's the first time that we have a comprehensive regulation for storage, and the idea that we find an opportune and cost efficient place for storage within our electricity system is a very good development. I would like to add that when I look at the provisions, and a lot of storage provisions come within the wrapping of the active customer, customer operating the storage unit. What I'm thinking is, and that's what we'll work on in the next couple of months, is it necessary, or is it a good idea to just concentrate on active customers? I mean, the big storage operators that we already have in Germany right now, the pump storage operators and stuff like that, they offer services too. They might offer services even cheaper. We'll have to look at the technology itself, not solely at the at storage operated by active customers.
Super, many thanks, Georg, for wrapping it up. So just to conclude, I mentioned this before, but I don't know if you lost me at that point as well. The slides and the recording of today's webinar will be available online for all of the participants. And just on my part, a very big thank you for our speakers, for the setup by SolarPower Europe, as well as the introduction by Aurélie. And we look forward to welcoming you all for the next webinar on storage in other markets.
Thank you.
Thank you. Bye.
Bye.
Thank you.